Well, it's great being here. How are you doing, you guys? It's a Monday afternoon. You still awake? Right? Okay. I'll try to support it a little bit with a lecture, which I think in the end is really about our common future. You know, do we make it or not? I think that's the subtitle of what you're reading right now. And what I'm trying to do within the next 35 minutes, something like that, is not only to face the challenge, that's the depressing part, I guess, you know, or maybe that's the engaging part, but I would like to really address the issue of the magnitude of the solutions we have there, and I think the seriousness of the challenge on the one hand, but also a concept which we call at our chair Eco Plus. So being ecological, it's not enough. We have to go the extra step, and that's what I'm going to explain with the second part of this lecture. The third one is really to bring the things together. We can only be successful if we take a systems approach. I'm absolutely convinced of that. If we don't look into the interrelationships, let's say in an urban environment, between building, between green infrastructure, between mobility, we have no chance for success, right? That's what I'm addressing there. And then really our topic of our symposium, of our collaboration, is really taking our own facilities, our own campus, as looking at them as cities, as neighborhoods, and to find solutions which will be then transferred to real-world environments, to city planning, to urban planning, but also it's giving you students the chance to engage yourself and use the potential to use already your studies to become an expert and execute things. That's the idea behind it, and then there will be some conclusions. So what are the challenges? I think I don't have to stay with each slide a very long time. You know that we are exploding with regard to our global population. The gross domestic product goes up, there's more people, there's more trade, there's more production needed to support us. The investments are going up, the population, especially in cities, goes up. We are already at a state where more than 60%, or depending what kind of sources you're using, 55% or 60% of the global population is living in cities. So basically, that's the major issue here, that if you want to support the transformation, you will look at urban environments first. They're still exploding in the global south, for instance. So the impact is the highest there. The primary energy use goes up. The fertilizer consumption goes up. So you could say, okay, that's great. There's more business, there's more development, there's more stuff needed. So that's good for us as planners, as mechanical engineers, civil engineers, architects. But you see, that's the drawbacks. That's the Earth system we're looking there right now. The question is there, can we stabilize with the figures you're seeing here? Are we able to stabilize the Earth system? And I will go back to that point later in one of the next slides. So you see the challenges there. I think they're pretty obvious and you know them already. This is the major challenge everybody is discussing right now, at least still discussing it right now. And that's leading, I think, to a lot of challenges. And very often we talk about global warming as the only basically issue we have to address, and it's not true. I mean, if you look at that chart, it's basically giving you an overview of how much the climate change is affecting human health. So if you believe the sources, the scientific sources we're having, we had about 63,000 additional deaths globally last year because of climate change, right? And we are not at the peak yet at all, right? It's going up. So human health is affected. Energy is pretty clear. Water balance is affected. Technical and social infrastructure. So when we are engineers, we're trying to fix something. We're trying to create something. Climate change, of course, has to be regarded at extra costs, extra efforts. The same is true for transport and mobility. Green spaces are becoming more important. Green spaces need more water, right, in order to support cooling, for instance. So air quality is depending on green infrastructure, so it's connected. You see that already. Tourism is affected as a kind of a source of income for quite a few countries. So sea level rise, I mean, we all know that. I just want to make sure that this kind of single directed discussion of climate change, I think this has to be revised with all the issues we have to address, in addition to the effects. I think that's a number everybody knows. I still like to show this slide because if you look into the red colors there, that's Earth at night, basically. That's the polar lights up there, right? So this is basically where we are producing or where we're gaining energy in forms of gas. This is where we have oil. This is Libya, right? Oil. This is Algeria. This is Venezuela. So if you look at all these spots there, so are these the stable spots we're having here on this planet, right? I mean, Libya, think of the past of Libya. Algeria, a country where you still don't want to go really to travel too much, right? There might be okay. And this is us, right? This is the rest of the planet, so to say. And I would say right now we're still on a track where the rest of the world, except for Norway, 100% hydropower, right? We want to have what these countries are having. Right now, in Germany, we don't want that anymore. But honestly, we're still getting gas from Russia right now. Isn't that strange, right? So it's a tricky thing here. It's not only about energy consumption and the CO2 emissions, the global CO2 emissions. It's really about also politics in the end. So the construction sector is responsible for about 50%, at least in Europe. I think the numbers are probably similar here in the United States, European material consumption. So we are running out of materials already. We're seeing that cement is getting more expensive. We're running out of sand, right? You cannot use the sand we find at the beaches. It's far too round. There's no cohesion, right? So we are running out of sand. And the construction sector is really responsible for 40% of the waste. Right? I mean, if we have 50% of the materials, at one point we might even have 50% of the waste. In Bavaria, it's 55% actually. We are tearing down more than we build new. This is happening right now. So you could say it's still fine, but is it really an issue? Is it really a challenge? I would say absolutely. What you see here is a chart which has been created 2017. So 8 years ago, basically. So the sources you're here, International Energy Agency was behind the generation of all these figures and numbers. So whatever you see in yellow here is the gross floor area built from the existence of mankind doing buildings, basically, you could say, going back to the Egyptians, and if you look into China, maybe even earlier. So that's all the built-up area we have had until 2017, and that's the projections we are looking at right now until, let's say, the next couple of years, until the year 2060, and you realize if you are rounding it downwards a little bit, so if you're conservative, we are building the same amount of buildings we have already on this planet. In addition to that, we are building the same amount or even more anew. So if we are fighting already about resources, right, about plastics we need, about glass we need, whatever we need in the construction sector or also in the mechanical engineering sector, we add to it. So if we feel like it's already kind of weary with regard to the provision of materials, it's getting worse. And the growth is not happening in Europe, right? So we do grow, right? But there's this explosive growth in Africa, right? And also quite some growth still happening in China, projections, of course, India, and even in North America, depending on the development during the next decades. So there we have a challenge, right? And then when we look at basically the ecological footprint, what is the ecological footprint? Anyone who could just phrase 2 sentences, what is the ecological footprint? Is this a term you're familiar with? Hands up, who is familiar with the ecological footprint? Avery, thank you. No, but who else is? So really a quick one. It's basically the impact of mankind with regard to material use, with regard to the need to store carbon somewhere. So nature, basically, the forests, the amount of the square kilometers, the hectares of forests we would need to capture the CO2, or the sea we would need to feed the world, right? Or the energy we would need to support our society, right? In terms of renewables or in terms of coal, right? And so we see that the footprint we are having, the impact we are having on nature, that's the red part here, that's the line, the red line here, that has in the year 1971, 73, we would have this break-even point of the footprint, that's the red curve here, and the biocapacity. So that's the ability of our planet with regard to the water surfaces, with regard to the fresh water, with regard to the forests we're having, the green we are having, to support our society, our global society. So you see that this graph here, this line is increasing a little bit, right, from 61 until now. So why is it increasing? The Earth is not getting bigger. Think in terms of biocapacity, bioproductivity. It's the use of fertilizers. It's the use of water to gain land in the desert, to produce tulips, roses in Central Africa, and send them via airplane to Europe to sell it on the flower market in Amsterdam. So it's all linked to this. So that's the fertilizers and the water, the use of water. But that's the footprint, and you see this huge gap. So we are already overexerting of what we're having as resources on this planet versus we are needing for the existence of our society. So we don't only have, let's say, a fight for energy, but we also have a fight for resources already, and that has to do with the relationship of the biocapacity down there with regard to the ecological footprint we are having as a global society. And of course, individual continents or individual countries have different figures, but this is the average. So that means basically we are over exceeding the biocapacity, so we would need roughly 1.8 planets. And if you have watched Interstellar, they find in the end, they find a new planet. I don't believe in this. So we have an incredible planet already at our hands. And if you look at these numbers, this is completely different sources, scientific sources. This is a different one. This is Rockström, right? So very well-regarded research institute in Stockholm. The Stockholm Resilience Center should be really looking into the literature you find there. And Rockström, one of the head scientists, has recently joined the Potsdam Institute in Berlin. And they're calculating, the same thing more or less. It's just that they're dividing this in these 9 sectors. So the planetary boundaries are really defined by the novel entities, toxic and long-lived substances, including radiation. The stratospheric ozone depletion, that's the second category. The third one is atmospheric aerosol loading. The fourth one, ocean acidification, disruption of biogeographical cycles, and so on. If you look at these 9 categories, he defines basically planetary health with these 9 categories. The latest report came out last month, basically telling us that we are already overstepping. Out of the 9, there's only 2 left where we are somehow okay. The rest is just way beyond, right? So you see the novel entities with regard to plastics, with regard to gases, with regard to radiation. We are way off. We're starting to get worse with the ocean acidification. That's the latest, which was added to that list where we're turning red. We have nitrogen, we have phosphates. We have freshwater change. This has a lot to do with the pollution of our freshwater, drinking water. Land system change. We're burning down our forests on purpose, not accidentally, especially in Brazil, happening in other countries also. The biosphere integrity with regard to biodiversity going down tremendously, and then we have CO2 and radiative forcing. So we are already, in addition to the CO2 emissions, our cities are getting so hot that the radiation patterns of long-wave radiation coming from the buildings, from the asphalt, from our streets, is actually affecting also the temperatures on a global scale. So it's not only the CO2 emissions reflecting basically the long-wave radiation coming from our planet, but it's also the cities basically radiating additionally heat into the atmosphere. So you see there's an urgent need to do something like that, right? So what does it tell us? We are overstepping all the boundaries already to an extent which we cannot sustain anymore any longer. So is there a chance? Is there a way out? And of course there is a chance. There's a way out, not by traveling at lightning speed through this outer space, so to say, but it's really to take a fundamental approach with regard to our thinking, with regard to our approach to what we can do. So it's clear, the first one, it's clear that the ecological limits are being exceeded. There's no question about it. We have to take that as a fact. And looking at us as civil engineers, as architects, and that's probably for all in this space here, we really need a fundamental rethink. Meaning basically that less bad isn't good enough anymore. To be a little bit better, that's what I mean by less bad, it's not sufficient to really find solutions for the tremendous challenge we're having out there. So you might get still kind of weary of what I'm talking about, but there will be solutions, don't worry. There will be a way out. But that's the second one. So we need basically less bad. It's not good enough. That it means that we must act now to deliver really a net positive approach with regard to our footprint. So that's at least true for the construction industry. That's also true for the car industry. Whatever we are doing, wherever we are using resources, energy, water, or whatever, green space to build new buildings to, we need to have a net positive construction industry. So that means in the end, we call it Eco Plus. That means in the end that we have to act in such a way that it's good to have that building there because it's storing carbon using renewable materials, for instance, because it's purifying the water on its ground. So if you have grey water and rainwater, the water gets sent back to nature in a purer way than we had it before. When we build something, we look at the biodiversity of the building lot before. We do an analysis. We really do a lot of counting. We look at animals. We look at plant species. And so the rule there would be to have more biodiversity on that site than before. And that's basically for all our impact we're having there. So in the end, I think it's a complete rethink, at least of us, who work somehow in the building business to say, okay, let's really take this challenge seriously and find a solution for that. So building the future together benefits in the end with regard to this net positive attitude and this principle, so to say. In the end, we create something which benefits the biosphere, the ecosphere, if you can call it that way, the economy. Without the business models, this is where basically Unternehmertum and entrepreneurship comes in. Without the corresponding business models and also our society, so where we look into health, where we look into how we behave, how we act as a society, are we aggressive, are we helping each other, what's the attitude? This has to be included in the thinking, especially in planning processes. So universities, that's the fifth point, and that's really what I believe in. The universities can lead, they must lead, right? I think we don't have a choice in the end. And accelerate this chance and the challenges coming with it. So the solution, and the sixth point is really our campus. So in Germany, the plural of campus is campus. I don't know if it's campuses in English. It is, okay. So this is why we have the singular, the campus there, is a living lab to design, to test and scale future-ready urban solutions. So at least in Germany, with our politicians, I don't believe that they will be developing the solutions. Ours don't. So it's really us. Who else would do it? Would it be, let's say, the economy, which tends to just repeat itself in order to run as long as it's possible? Think of the car issues we are facing in Germany right now. We went full towards electric. Now even the politicians go back and say, let's go back to the combustion engine, right? So we cannot count on them. So it's really us in this room and everybody involved in there to really, with our research, with our brain power, with our team spirit, we have to really develop the solutions, show on a campus that it works. That we were just visiting your power plant. It's amazing what you've done. That's exactly the thing here. You have renewable energies. You have a surplus of renewable energy. So in a let's say with regard to energy supply, you are already eco plus, right? Here in this at this university. So you should be really proud of what the university has done there. It's outstanding. I don't know if any university who has been there already. So Stanford is really leading the way with regard to energy to really push of what we are doing from a conventional, degenerating, fragmented, technical-oriented, object-oriented view of things, move into regenerating systems, into living systems, in interrelated thinking, into holistic thinking, in order, in the end, to have this really positive impact on people, on nature, renewable energy uses being used, renewable materials being used, circularity as a topic, biodiversity, positive impact on the ecosystems, and closed water cycles. And there would be a few more points to be added. And the thing there is that it's interrelated, it's connected, right? If you want to have in a city, if you want to have more green, you must, there's no option, you must talk to the mobility people, right? If you have parking lots all over, like in Munich, where do you would put your plant, your tree? Would you put it on top of a parking garage? Or would you be able to kick a car out to place a tree there? Munich, no way. We have BMW, we have Audi, right? The lobbying is so strong. So we really have to talk to the mobility experts. If I want to have more green, if I want to have more green and I get more green, I need the water for it. So we have to talk about the blue infrastructure. Do we have a sponge city? Yes or no? Can we store the water? Can we harvest the water? And then we have to explain it to the people. We have to get them in, right? We have to talk to the material people. So it's all connected. Society, mobility, water, green, material, and energy. It's all connected, right? And that's the thing where it becomes really interesting, especially for science. So a systems thinking approach is really needed, coupled basically with life cycle assessment. So all the different material uses, all the different energy systems, the water systems have to be analyzed over the whole life cycle. Otherwise, you don't get a full picture of the impact or the benefit of, let's say, for instance, renewable energies. So it's in the built environment. It's the gray energy, the energy being used for producing cement, for cutting down trees in order to transport the tree basically as wood, as timber to the building site. So this has to be all included from the production over the construction, the use, the disposal, the recycling, or the reuse. Really thinking in cycles, in circularity. That's very important. And so that's leading basically to an approach. So it's life cycle assessment. It's a holistic view of things, and I will come back to that later, which we can use for, in the end, use our campuses using life cycle assessment with regard to ecological values and properties, life cycle cost assessment, this is where the economy comes in, and even social life cycle assessment with regard to health and society, governance structure are part of that also. And I think this is a roadmap. Of course, I'm not going through all these detailed points, and we can freely distribute the slides, of course. There's all the sources linked to that. That's more a proposal I want to bring to the table. So if you want to follow up the kind of campus as a living lab, and we could even dream of it to get a lot of universities involved using these key performance indicators you see here on the slides, whether it's with regard to the general methodology, what is the scope, what are the governance structures, or with regard to the systems approach, so what does my system look like, what kind of assets do we have. So that's the homework we would be doing before we really starting doing this kind of competitions there. The ecological aspects, environmental aspects, life cycle assessment is an established instrument, a methodology. You see here the Euro norms. And I think it's pretty similar probably to what you would find here in the United States. We also look into the economy with regard to life cycle costing, social life cycle assessment with the indicators you find here. Is a campus really healthy? Is a campus really beautiful? Is a campus productive? What are the temperatures in summertime? It's all parts of that of 0.5. And the sixth one is really integration, find synergies and trade-offs. So that's the most challenging part with this kind of systems approach. And so the last 3 points there would be the data. So we need the digital twins in order to really monitor what we're doing, to communicate that to the user when it comes to, let's say, CO2 level in this audience here. We should know that right away before we fall asleep, that we need to have more fresh air, for instance, or the temperatures are too high, too low, or what is the CO2 emissions right now to producing a comfortable indoor climate. The KPIs also with regard to carbon, energy, water, and costs. That's the 4 I think we really have to address. There might be also a few others. And then, of course, also different steps we have to take from the concept through the scheme to the design and to the execution. So that will be a roadmap, so to say, for campus as a living lab. So the most important point there, as I mentioned before, are also the issues of complexity and system thinking. That's not luxury, that's a must, right? So if we look, for instance, and that's the transfer now from the campus as a neighborhood, so to say, as a little city on its own right, to really transfer that to neighborhoods, that's basically taken from our studies of urban planning, if you want to have urban analysis. So you look into mobility, right? Do we have mobility on a campus? Sure, right? Energy, do we have energy on a campus? Sure. Do we have materials on a campus? Sure, right? Do we have the chance to mitigate the effects of climate change on a campus by putting in more green, more evaporation cooling? Yes. And you have a beautiful campus where you have already a lot of green. I don't know so much about water consumption. That might be a little bit of an issue, right? So this is where already water comes in. But in general, it's about the well-being and the quality of life. So we want to know about that. We want to address the issue of the building sector. Again, gray energy, producing materials for the building sector, maintaining buildings, and so on, keeping the cycles going. Green and blue infrastructure we have addressed. And the process quality. So is the planning process done? Is the monitoring being thought of, and so on. And what you see on the right-hand side, it's not a game with colors. You see all these different areas and how they are connected. And you could weigh that. You can show actually how important some of these relationships are. And we are using basically computer tools now to really show the interrelationships in order to weigh the different connections there with regard to synergies, positive effects, but also with trade-offs. So a city basically is looked at as a system, which you can see here, where the urban planning as a framework, the physical environment, it's all its properties, the functional aspects looking into mobility, for instance, or movement in a city in general, or use of water, the infrastructure needed to make these connections to bring all these resources into a city, or taking wastewater out, for instance. The energy, of course, is a major issue, and also the material cycles. So when you look at this digital twin I'm talking about, it's about information handling, the knowledge matching, so to say, of the different disciplines related to all these topics. We need a dynamic modeling. Dynamic means that we will regard, or we do regard, at least at our chair, the moving climate target, right? The CO2 emissions still go up. The planet is getting warmer and warmer. That's dynamic. The costs are going up. It's dynamic. The resources become less. That's dynamic in a negative sense. So everything is dynamic. So what is happening today is very different from what is happening tomorrow. So we have to take time into account. We typically would work with scenarios. It's not like, let's find this one solution, but let's look at the 10 options we are having, comparing them, and then optimizing it through the process. Guess it's design related, what we're doing here. So, and then analysis of the scientists and synthesis through the planners in order to plan that urban environment. We call it knowledge-based design, right? So it's about the built environment where human needs and behaviors come in, and the built environment is the framework, so to say, and we're running the whole system. If you look at a city as a system, by looking at the processes. And the same thing basically we are doing already to some extent at our chair at least, and also my colleagues are doing that. We're using already our campus as a living lab. So we have an architecture department, we have civil engineering, environmental engineering like you are having. So we're using, in this case, our campus in Garching. I'm not going to read all these numbers to you. It's one of our biggest campuses. We have about 7 to 8 right now. So then we have one in the city center. That's the historical one, Munich. The TU Munich has been founded more than 160 years ago by King Ludwig II, who was very technically oriented. With even the buildings look very old. The technologies used for building Castle Neuschwanstein, for instance, the roof is made of steel. Nobody knows that, right? So really advanced at that time. So we're using that campus where 80% of our total CO2 emissions are generated. So this is where you have been, I think, like 10, 15 years ago, gas-fired Cheng cycle power plant. The decision is out that we are taking that out. That's good. It's a good news, basically. So we're following your path in a way. And so we're using that now for quite a few years already as a test bed, so to say, as a test ground with regard to bringing total sustainability in there. We do that with this kind of governance structure. So that's our president's office, so to say, with my colleagues, vice presidents, the TUM Board of Management. So we have, our president has basically decided that we need this vice presidency here in order to accomplish the governance structure. We have the sustainability office very close to what you are doing. We have two TUM Green offices, so that's about 20 students at each different location with a lot of projects. It's incredible what they're doing, like here at Stanford. We have the TUM Sustainability Board. That's my colleagues coming from different areas. There's Alvine there, business. I mean, we could go through all that. Miranda is there, governance structures. So that's the hardcore colleagues who are helping us to, and there's quite a few more also, to helping us to push for these things. But we also have for the campus development, we have the Task Force Sustainable Campus Development. So we have also colleagues who are dealing with that. Magnus, for instance. Magnus, where are you? Yeah, doing circularity, right? So I think that's all these issues are somehow covered, which I have just addressed by the experts, which are in part in this space. And I think there will be a little bit of discussion. So we have a sustainable future strategy. This was basically done 2 years ago. We have a climate action plan already in place. The Sustainability Day was really the last one here 1.5 years ago. The next one will be in April. This is where we had 5,000 people on campus really celebrating sustainability as something really cool, really sexy, right? I think this is where we have to go. Sustainability has to be fun, not only to have a little bit of game there, but really fun in the sense of you can have as students an impact. I think that's the major thing there, and that's the Sustainable Futures report basically done for the Sustainability Day, where we're basically reporting every 2 years where we're standing with regard to our sustainability goals being really framed in the Sustainable Future Strategy. So there we're dealing in the action plan, and I find that interesting. We're not only dealing with energy supply, energy demand, mobility. That's something you would expect. A third of our emission goes into mobility, but there's also resource efficiency, of course, adaptation to climate change, research, teaching, education, entrepreneurship, management, right? So that's again where we're very close as universities, I think, with regard to that approach. So that's just one slide showing where we're doing this. There will be more in the afternoon where we're having all these roundtable discussions related to energy scenarios. So we have a lot of old buildings there which need to be renovated. So that's basically something we have done in the research roadmap to getting the building envelopes basically renovated to passive house standard. So we want to have really good buildings out there. We are looking into mobility. That's actually also a project which was run in part by students, finding out what the modal split is on each weekday out there in Garching. You see the peak day is Monday. You see here the mode of transport. So we have the car in orange here. We have the bikes are the green ones. We have public transport. PT is public transport. There's an U-Bahn line, a subway line. So we do that. We look into climate change adaptation, and we do that in part with students. Or one of my colleagues, Stefan Pauleit, is doing a lot of research. And I think the scary part there is really on the right-hand side. You think that you are having hot days here in California every now and then, or warm days. We see that's basically the mean radiant temperatures. And there's asphalt there's concrete walls. They get really hot during daytime. So we're reaching temperatures, and you find it hard to believe, but we have measured these temperatures of 70 degrees Celsius, right? So that's not comfortable anymore, right? So that's really very important, telling us we need more green, we need more shading, we need more water, we need different kinds of floors. They need to be more permeable than what we're having today. We need to harvest rainwater. The sponge city has to come in. It looks like a green campus out there. That's the mechanical engineering building where the sustainability day is happening. And if we do it on a hot summer day on July, that's the main entrance basically here, right? Yeah, this is where the U-Bahn comes. And so imagine the dark red there. You're close to, let's say, even if it's not 70, if it's more like 65 degrees centigrade, I would say 145, it's still pretty warm, right? So that's what we're doing. So we're using the campus as an object for research and for solutions at the same time, making proposals, and that's also, again, for the campus, what the greening of the roofs would do, what the greening of the facades would do to implement rain gardens. So that's all scientifically backed up, in part with the students. So how does it affect biodiversity out there? What is the increase in quality of life out there if we're doing these things to bring temperatures down, bring biodiversity in there? What is the quality of urban space? Again, a study being done of one of my colleagues, Ben Buxain, with his students, just doing interviews, so more on a social side. You know, what do the students find attractive? What are they missing? How could we improve the quality of life, the quality of urban space out there as a lab? And that's the last slides already. And that's at our chair. So basically, that was the students' restaurant before they decided to tear it down. So the decision was revoked. We don't want to tear down. Circularity does not mean, Magnus, and I think you would agree with that, doesn't mean tearing down, using a bit of the concrete, of the steel, and doing another building with these materials, because you still need new cement, right? And the energy intensive part is really the cement use. So the president's office took that back. There was some kind of rethinking really happening, trying to give that building another life. And there was an opportunity for our students to step in and say, let's do a project with that. And that was even Freizeit, means free time. There was a center for all the activities which at a research campus were not there. So the campus in Garching is very monofunctional. There's no shopping there, there's no culture there, there's no music there, there's no theater there. You know, there's no reason to be there actually, except for studying. Doesn't make sense in my view. There's other activities, there's all human beings out there with their needs. And so they said, let's turn this building into something which is serving the students and their needs to be productive, to really be happy out there, right? And that's what I felt was really great. Students for students doing something like that in their design. So there's a program. We had experts in urban planning, in mobility, in water use, in landscape, in outdoor comfort. So that's a different design approach. You have all the disciplines at the table in order to make that change, that holistic design able. So we really challenged the students by being able at the end of the semester to be able to do life cycle assessment with regard to ecological, economic, and environmental factors, including social life cycle assessment. And so all this analysis you see there, so the transfer from research to teaching, that's all done by the students, and all the calculations are basically proven. So that's our approach, you know, where we take experts into the teaching, into the studio, in order to get that done. And that's, I think, one of the last slides there. So even daylighting is examined, not only energy, but also comfort levels with regard to daylight and artificial light. And so you see a list of the chairs. We are collaborating there. So the core chairs are 4, But for this project, we had additional colleagues from urban planning and from other areas to support us. So the conclusions are basically, we need to have this Eco Plus mindset there. We need to look at cities, at neighborhoods, at our campus as a system. The integration is really important. The campus is the advantage. We have clear boundaries. We have real users. We have a controllable infrastructure. And the outcome is a replicable playbook for cities. So that's basically the opportunities there. We demonstrate energy, what we can do with energy. We demonstrate what we can do with water, with material, with mobility, and even entrepreneurship business models. So that's really the demonstrative part of it. And how we prove it is really the KPIs. Right, so that's the last slide. So that's something we have to agree on, I guess, in the end. I mean, there might be different units. We have watts, you have British thermal units, for instance, but that's easy to be done. We need an online dashboard. You have that already online, right? So we are implementing that for the campus using basically the digital twin we are creating right now as a means to have everything in the system, so to say. The decision gates are pretty clear. We need a campus system map, creating a baseline, and we have the baseline already out there. And then we have launch of the Stanford TUM Living Lab Alliance. I think that's happening right now, I guess. That's right now. So historical moment, guys. Note the date, time, right? So that's happening right now, and I'm really happy with that. And I think with that, I thank you for your attention. Thank you.
So are there any questions? Thoughts? Yeah. Okay. And are you
Thank you. So I was just wondering, so you're kind of seeing some of the changes you're talking about happening, but I also think it's accompanied by a lot of greenwashing. Just wondering sort of what your thoughts are on that.
Greenwashing?
Greenwashing.
Yeah.
And if there's anything sort of we can do to safeguard against that greenwashing.
There's a lot of greenwashing out there. Our banks are green. Sustainability, I mean, I said the no word, right? Sustainability. I said it again. I said it again, right? No, everything is sustainable in Germany. So with the banks, you know, lately also, unfortunately, the military sustainable now, and that's tricky. I refused to go to do my military service. I didn't believe in solving conflicts that way, right? I had to rethink that also. So, but in general, sustainability is a very it or invert, whatever you want to call it, and this is where I go in. And I would say I only believe you if you show me the life cycle assessment with regard to environmental impact, with the costs, because we typically just talk about investment costs. We're not talking about the running costs, right? We're selling buildings based on just the construction costs. We don't tell our clients how much they would pay for cooling the building for the next 50 years. You know, so that total transparency is really the key, and that has to be based on a life cycle assessment. That would be my solution. Or if you say, of course, it's more comfortable, show me the figures and numbers, you know, not only in simulations, but also measurements. So you have to back up your simulations by empirical data, you know, and that's what you always do. You know, biodiversity, I mean, you don't know what the rabbit is doing there, right? But give him the habitat. So we have a great project there. It's called animal-aided design. And this is, again, where they're doing the counting, right? And the post and the before and after studies, you know. So I think it has to be always backed up, whatever we do, whether it's biodiversity or whether it's social aspects even. There's different methods, of course. They're finding out whether people are happy or not, you know. So this is where science comes, and this is where we as a university can really make the difference by bringing in full transparency and bringing that to the table. That's my answer. Thank you.
So we can probably do one more question.
There was one here.
Thanks. Can you hear me?
Yeah.
Okay. So as a person who's working for a city right now, very excited about all of this. How do you envision the handoff or the implementation?
We're collaborating with Munich already, so Munich is our test bed. So we have that's the campus as a living lab, but we have recently done, you have heard of the Green Deal, right? So we have a program by von der Leyen, also our president. It's called the New European Bauhaus. So the idea is to going back to the Bauhaus actually in Weimar and Dessau. But at that time, they say we need a new future for the built environment. That's the Bauhaus idea. It's not about style. Very often it's mixed up, right? So the Bauhaus was really a new attitude towards building for the future. So that was basically the reason why von der Leyen said we need this kind of new European Bauhaus approach. So we got European money with a lot of people, disciplines like I've shown you, to transform a city quarter which was still is for 20,000 people, fairly big, in Neuperlach. So typical 70s, 80s development, high-rise buildings, box type of apartments and so on. So we were supported by developing solutions not only for the energetic renovation of these buildings, but predominantly to find new uses for the buildings which had been abandoned already. So insurance companies were there, Allianz, all the big ones, for instance, or Wacker Chemie, and so on. They're out. They don't need these huge mega structures anymore. So they're empty. Again, what do? Do you throw them away? Or do you find new uses? How do you define the new uses? So the only chance you can do is by working with the population, right? So like you would ask students, what they feel about their campus, their buildings, and so on. We did the same with social scientists, right? You need the experts in all of the fields. We did this, and there was a project running over 2.5, 3 years. So you would, unfortunately, it's in German. There's publications out there, but this is where the transfer is already happening, and it started again with what we did before with the campus. There's also a project, Green City of the Future, where it's all about green infrastructure. That's a second stream of our chair, what we're doing with Stefan Pauleit, with the heat map, right? So there was also solutions on a green level for the city of Munich, and the city was part of it. We always do these things with the city administration. That's key. They have the people on there who can then later implement that. So that's the connection with the cities. Yeah. Sure. Thank you.